Okay, so Monday we reviewed functions and linear models. Okay, so today we're doing our quadratic functions. Remember, that was a part of the mathematical model topic. Okay, all your functions all together in this one topic. So we're going to refresh your memory on quadratics, how to solve them, graphing them, and so we're going to be doing a lot of stuff on your desk just like before. Okay, so if you need a sheet of paper out to write down a little bit of notes, things like that, please go ahead and do so. To start off, let's talk about some properties of quadratics, shall we? Draw an example of a quadratic function. On your desk, draw an example of a quadratic function. All right. So, yes, a quadratic looks like a what?
Parabola.
It is a parabola, and it looks like a U. It can either look like a U going up, or it could look like a U going down. Okay? That is a quadratic. X squared. Okay? Those are quadratic functions. What is the standard form of a quadratic? Standard form. Now, this I actually want an equation. What's the standard form of a quadratic equation? Alexis, what is it? AX squared plus BX plus C. Okay, that is standard form. Very similar to standard form for a linear function, AX squared plus BX plus, or AX plus BY plus D. Same type of letters, guys. All right. Now remember, each of these letters kind of told you some important information about the quadratic. What does C tell you? It is the constant, but it was also something special about the graph itself. Say again? It is the y-intercept. It's the only thing that remains once you plug in 0 for x to get your y coordinate for your y-intercept. And the A told you what? Negative or positive, which means what? Yes, A tells you whether or not it goes up or if it goes down. How do you know if it goes down? A is negative. A was negative, okay? B was involved with the part of your vertex and things like that, but we'll get to that soon. All right, so we talked about this. If A is less than 0, the quadratic looks like what? Yep. Down. Meaning that this point is called a what? A maximum. And if A is greater than 0, then you get a min. Okay, so if A is greater than 0, then this point is indeed a min. Okay? These are all things that should help you when it comes down to, if you're working with quadratic and then they ask you to graph it, maybe you plug in points, maybe you're doing some other things, but it should all make sense. All right? What is the formula for the axis of symmetry? What's that formula? Write it down. Formula for axis of symmetry. What is it? Write it down on your desk. Okay. You guys, remember the axis of symmetry is an equation, so you need to have what to start it? What else with the equal sign? X equals, and then you need the actual equation, which some of you guys did have. What's the equation? Negative b over 2a. Okay? But no one had it 100% correct because it does include the x equals. You have to have the x equals, otherwise it's not going to be right. The axis of symmetry, Kayla tells us what? It is the x coordinate of the vertex, okay? So not only is it that imaginary line that cuts through the parabola, making it symmetrical on the left side and the right side, but it's also the x coordinate of our vertex. How do we find the y coordinate? Yes, we plug this x value into the equation to get the y coordinate of the vertex. Okay? And we already talked about this. What's the y-intercept of a quadratic function? It's the c when it's in standard form. Okay? Now, there were two different ways to write a quadratic. There was standard form, which we just went over. And then, what were the other two forms? That's for a line. What are the other two forms? What's one of the forms? Vertex form. That was one of them, okay? And it was called vertex form because it gave you the what? The coordinates of the vertex. Vertex form was y equals a parentheses x minus h squared plus k. Your vertex was hk. What was the other form? In the process of figuring it out. Come on. Standard form gave you your y-intercept easily just by looking at it. Your vertex form gave you your vertex very easily by looking at it. What other form gave you a piece of information about the quadratic by just looking at it? No.
I don't know what that one's called, but I know what you're talking about.
No, start with. Think about what? No, not X form. Think about it. All right? This is a quadratic right here. Vertex form would give us our vertex. Standard form would give us our y-intercept. There's what? X-intercept form. The X-intercept form gave us what our X-intercepts were. We went over this. X minus P, X minus Q. That is called X-intercept, aka factored form. Okay? We went over all three of those when we were going over mathematical models for the very first time. Okay? And like I said, standard form gave you the y-intercept, the red. Vertex form gave you the vertex, off gay, the purple. And then factor form gave you your x-intercepts. Okay? Because, these are already factored. So to find the solutions, you just set the factors equal to 0 and solve. Who remembers that? We had a whole test on quadratics alone.
I remember that.
Okay? So, find the x and y intercepts of this quadratic. Find the x and y intercepts of this quadratic here on your desk. It is in standard form, so your y-intercept is what? -5. Y equals -5 or 0, -5 as a coordinate. The x-intercepts is where your graph crosses the x-axis. In other words, factored form, which means you are going to need to factor this. When you factor, you're looking for two numbers that multiply to give you C, that add together to give you B. What are those two numbers?
5 and 1.
What is it?
5 and 1.
What is it, Nathaniel? -5, +1 on the factors. And then you set it equal to 0 because to find x-intercepts, you set y equal to 0. So you have to factor it. You have to do this. Has to add to give you -4. Multiply to give you -5. Set both of those equal to 0. X equals 5 and x equals -1. Or 5, 0. -1, 0. Huh? You could, yeah. That's why I say either or. Okay? You guys cannot forget how to factor. You're not going to it's very rare you're going to get one where A is bigger than 1. It's very rare. So you got to know that you're looking for two numbers that multiply to give you C, add together to give you B. All right? Now find the vertex of this. Same equation. Find the vertex of it. All right? Remember, to find the vertex, to find the x coordinate, you need to do what?
Oh, -b over 2a.
-b over 2a. Not only, again, does it give you the axis of symmetry, but it also gives you the x coordinate of the vertex. And you need an x and y to make the actual coordinate of the vertex because it is a coordinate. What's B? -4. What's A? 1. So then that turns into what? 2. So your x coordinate is 2. X equals 2 is your axis of symmetry. Then to find the y, went over it as well, you just have to what? Plug it in. Okay? So you plug in 2, do your math, and you get that your y coordinate is what? A -9. And you write it as a coordinate with the parentheses. Okay? Questions? Now graph it. Graph this quadratic. Graph this quadratic. All right, so for quadratics, we're taking this problem that we found all this information for. We just found the vertex. It was 2, -9. We found the x-intercepts, which were 5, 0, and -1, 0. And we also found the y-intercept, which was 0, -5. You just graph all this information, 2, 9, 5, 0, -1, 0, 0, 5, and you just connect it all together with a smooth curve, okay? Should the graph open up? Why? Why? Because A is positive. A tells you that it's going to open up or open down, all right? Your negative numbers are on the left side of the y-axis, and your positive numbers are on the right side of the x-axis, the y-axis, okay? Now, transformations. Describing what happens to the graph, okay? We'll make sure that we cover this. Mind you, the most basic parent function is y equals x squared. Where's the vertex for that particular quadratic? 0, 0. Does it open up or down? It opens up, okay? But if I look at A, I'm no longer at 0, 0 for my vertex. So I moved not just the vertex. I can't just detach the vertex from the rest of the graph. Moves the entire parabola down. So yes, this will be down 3. You're right, but it'll still be positive. What about this one? X plus 5 in parentheses squared.
Does not make it wider.
No, it doesn't make it wider. No, it doesn't have nothing to do with y.
Wait, if that whole thing is squared.
If you need to, you could FOIL it to see what happens. You know, maybe then you'll be able to figure out what the vertex is. Or maybe you could say, hey, isn't this in vertex form? Look at it. What's the H here? No, it's not 5. It's not 1. What is vertex form? I wrote it down on the last slide. What's vertex form? Y equals A, x minus h squared plus k. If I look at that, what value did I have to plug in for h so that I got x plus 5? -5. So what's my vertex? Comma, 0. Because what's k? There's nothing there. 0. Okay? Look at the form. Look at your B. It's x squared, x plus 5 squared, nothing else. This is the form for vertex right over here. X minus h squared. The only way to make this a positive 5 is that you had to plug in a -5 for h. Because a negative and negative make a what? A positive. So h is a -5. Since there was no number on the outside, that means that k had to have been 0. Your vertex is -5, 0, which means you are now here. Am I still pointing up?
Yes.
So my graph moved which way? To the left. How many? You just can't say left. You got to say by how many as well. What about C? Move to Right 1 and up 4, because what's my vertex now?
1, 4.
1, 4. So I'm now 1, 3, 4. Do I still open up?
Yeah.
Roughly. Questions? I'm telling you, once it goes into vertex form, you know your transformations, because you got to identify what the vertex is, then you'll see exactly, okay, oh, I moved left or I moved right. Okay? Very rare you guys are going to deal with stretching and all that type of stuff. All right. IB questions. I'm timing you. All right? Doing this one on your desk. 6 minutes. All right. So this is an IB question right here. This is the quadratic curve with equation y equals ax, x minus b is shown in the following diagram. They give you that equation. That's exactly how you have to write it. Okay? It says the x-intercepts are 0, 0, 6, 0, and your vertex is at h8, which means that is the highest point that the graph goes. You have to find the value of h. Now, h is the x-coordinate of the vertex, aka what? Axis of symmetry. And what does the axis of symmetry do? Splits in half. It cuts straight through the vertex and makes the graph what? Equal on both sides. So if this one's at 0 and this one's at 6, that means it has to cut at that point to make it the exact same on both sides. What point is that? 3. H is 3. Another way you can do that is you can take your x-intercepts and just find the average of them. That's the other way that you can do it, algebraically. Now, to find the equation of your curve, in studies, if a was 1 or -1, they're not going to put an a on the outside. They're going to put a negative. Does everybody understand that? Like if there's an a, then that means it's a value other than 1 or -1. So they give you the vertex. And they give you this form that's in what form? What form is that? It's an x-intercept form. It's in a factored form. Not your classic 2 parentheses factored form, but like a GCF factored form. If I set both of these factors equal to 0, I'm supposed to get my x-intercepts, right? What are my x-intercepts? 0 and 6. Well, clearly if I divide by a on both sides, x is going to equal what? 0. So that's where ax takes care of that x-intercept. But over here, b is going to have to be what value? 6. Because when I add it over, it has to equal 6. So b is 6. A positive 6. So right now you have ax, x minus 6. That's what you have. You have to find the value of a. A is not 1. If it was 1, they wouldn't put an a there. Okay? I've seen many of studies exams. They do not do that. What you have to do is use another point. Not your x-intercepts, because that's the form you're in. You have to use your vertex to find the value of a. Plug it in. Plug in 8 for y and 3 for x. Everyone do that now on your desk and find a. And don't forget your order of operations, because I've seen on the 4 desk already improper ways. Look at your A value. I don't know. I guess I'm not explaining it right. Order of operations. 3 minus 6 is a negative 3. 3 times negative 3 is a negative 9. Divide both sides by negative 9, and A equals negative 8/9. Negative 8/9. Order of operations. So your equation is y equals negative 8/9 x minus 6. Again, anytime they give you a value of A, like they give you A as a variable, it's not going to be 1 or negative 1. It's not going to be that. Like you're going to have to plug in another point to find the value of A. Let's do another one. 6 minutes. Here's the next one. You got a quadratic function represented by f of x equals ax squared plus bx. No c. Is represented by the mapping diagram below. So incorporating functions and quadratics together, they're all a part of the mathematical model family. You have to use the mapping diagram to write down 2 equations in terms of a and b. You could have technically done 3, but they only wanted 2. Okay? So that means you're taking these x values, plugging them in, and taking the y values or the f of x values and plugging them in as well. So you could have had a minus b equals negative 4, or you could have had a plus b equals 8, or you could have had 4a plus 2b equals 20. You needed 2 of these 3 equations. Did anybody get 2 of these 3? You had to plug it in. Good. Okay. That's how you use the mapping diagram, to plug it in especially when they give you an equation. All right. Now you have to find the values of a and b, which means you're going to have to do what? Elimination or substitution. It's a system. If you use the first 2, it's actually pretty simple because one of your variables is positive in one and negative in the other. So 2a equals 4. A should have been 2. And then 6 would have been the other one, because you would have had 2 plus b equals 8. So b equals negative 6. What do a and b represent? Where did they even come from? Why did they choose A and why did they choose B? Where did they even come from? Not points. No. I see you guys looking at the screen. It's on the screen, I promise you. Yes?
B should just be 6.
It is 6. I don't know why I put a negative 6. Thank you. What do you mean parts of the problem? In the problem. In the what? In the equation. Yes, in the equation. That represents a quadratic. That's what A and B are. Not points, but they're actually the coefficients of your equation. You have f of x equals 2x squared plus 6x. You need that there. Well, actually don't really need it, but that's where it comes to. Because you just do negative b over 2a. But there was a method to it. Because it won't always be a and b. They could use p, q, and r. They can use any variables they want to use. Negative b over 2a. Your x coordinate, only x, not y. Just the x coordinate would have been a negative 3 over 2. Because you reduce. Let's do another. Six minutes. Okay. Well, it's definitely stale for sure. All right. So this one, parts of a quadratic, a part of a graph of quadratic is shown below. On the graph, it gives you the x-intercepts, one of them at 0, 5. Then the x-coordinate of the maximum is 3. So we know this is 3, because that's the the x coordinates of the maximum, which means that this one has to be the one that's 5, 0. That has to be the one. Then they give you the equation. See what I mean? What's A? And they give you that. They're not going to have you find a negative 1. And then B and C are what? What does that mean? Integers. Positive and negative whole numbers. So now you have to find the value of B and the value of C. Easiest way to do this is to figure out what that other x coordinate is of the x-intercept. What is that? It is 1. So in factored form, this is x minus 1 and x minus 5 because it's the opposites. And then there's a negative on the outside because it does open down.
How can you assume that's 1 right now?
That's right there. All right, so now what I need to do is I need to FOIL this, x squared minus 6x plus 5, and then distribute the negative back through. So what's B?
B is
6, and C is
negative 5.
-5. Now it tells you that the domain of this function is from 0 to 6, which means that whatever this value is and whatever this value is, that's how low it goes because it says that it's included. So it's not negative infinity to whatever the maximum is, it's whatever this value is to the maximum. How do I figure out what this y value is? We do have it. It's the C. This is -5. Does everybody understand why it's -5? So it goes from -5 all the way up to, nope, that's the x value. How do you find the y value?
You need to plug in the x coordinate into the equation.
Plug in the x coordinate. So this is going to be -9 plus 18 minus 5. The answer is going to be 4.
Wait, how is it -9? It's -3 squared.
It's 3 squared times -1. Order of operations. Yes? -5. Since the lowest x value was 0, you're basically plugging 0 into the function, aka the y-intercept, which is C.
Wait, so is -5 for the answer for B?
Yes, that is the range. So the lowest it goes is -5. The highest it goes is +4. And range is your y's. Range is your y's.
What would it look like if it was set?
In set, you have to write it as a compound inequality. We plug 0 in because these were the restrictions on our domain. So because we have restrictions on our domain, we're going to have to restrict our range as well. Yeah, so you can plug in 0 into the equation and not 6, but the 3, because that's the highest it goes. Clear desk. It's another one. Lots of these. 6 minutes. All right. Consider the quadratic equation. It is written in a backwards, so if you wanted to, you could have turned it and wrote it forwards. Okay? It says, given that f of 2 is -5, to find a, you would have had to plug in 2 for x and -5 for y to solve. That's -5 equals 4a plus 3. Subtract over 3. A should have been a -2. It should have been -2. So your equation is -2x squared minus x plus 5. Axis of symmetry, equation of the axis of symmetry, -b over 2a. So that's 1 over -4. X equals, because it's an equation. And then you have to write down the range. Now, real quick, does this open up or down? Down. Are there any restrictions on your domain? Because a is negative. Yeah, A is negative. Are there any restrictions on your domain? No. So your range is going to be from negative infinity all the way up into the maximum value of this quadratic. So then you plug in 1/4, negative 1/4, to get the y coordinate of your vertex. What is that?
Oh, why?
Yep. 41/8. You guys, quadratics. Quadratics is usually a big one. Studies or SL. Okay? Something that you've been doing for a while, from algebra 1 all the way up until now. Okay? You need to know how to find your vertex. You need to know how to find your x-intercepts, your y-intercepts, using the different forms to pull out this information, how to graph them, how to find a missing variable by using a coordinate, how to find the domain, how to find the range, incorporating the functions part of mathematical models. Okay? Your homework tonight is going to revolve around quadratics. It might throw in a function here or there, apart from functions. So hopefully these IB problems refreshed your memory a little bit on this.
It'd be great if we went to take